Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the May-June 2022 Mechanics Paper 4 Variant 1 from the Cambridge 9709 syllabus. This question here is about these particles A and B of masses 0.4 and 0.2 kilograms, which are moving down the same line of greatest slope of a smooth plane. The plane is inclined at 30 degrees to the horizontal, and A is higher up than B, higher up the plane than B. When the particles collide, the speeds of A and B are 3 and 2 meters per second, respectively. In the collision between the particles, the speed of A is reduced to 2.5 meters per second. Find the speed of B immediately after the collision. Okay, so you got this inclined plane. Okay, 30 degrees. I don't think we need to bother about that right now, but we've got A, which is higher up than B in the plane. Okay, so before the collision, immediately before the collision, okay, just before the collision, we have A and B. A has a mass of 0.4 kilograms and B 0.2 kilograms. A is moving at 3 meters per second in the same direction as B. They're both moving down the plane, okay? As it says here, they're both moving down the plane. That's 2 meters per second. And after the collision, A's speed is reduced to 2.5 meters per second. So I'm taking this as before the collision. The information here is before, and the information underneath I'm writing as after, before and after the collision. And we've got to find what the speed of B is after the collision. Okay? So of course it's going to be down, because that's going down as well. So now let's have a look. We're going to use the conservation of linear momentum. Okay, and we can say that the total momentum before the collision, I'm going to take down as positive, is going to be 0.4 times 3 plus 0.2 times 2. And that's equal to 0.4 times 2.5 plus 0.2 times the velocity of B at that point where they collide. Okay, so now that's going to be 1.2 plus 0.4 equals, that's 2.5 times 0.4. That's like 4. That's going to be like 1, isn't it? Right? That's correct. It's like 4 times 25 is 100, and you got to go back 2 spaces, so it's 1, yes. And that's plus 0.2 VB. So that's 1.6 minus, that's 1.6 minus 1, which is 0.6, equals VB. So that means equals 0.2 VB, sorry. Let me just not rush here. Okay, move that down a bit. So we have here, let's just do slowly, 1.6 minus 1 equals 0.2 times the velocity of B. That's 0.6 equals 0.2 times the velocity of B. So the velocity of B is equal to 0.6 divided by 0.2, which is 3 meters per second. That's the velocity of B immediately after the collision. So as it's after the collide, B is going down with 3 meters per second. Okay, then after the collision, when B has moved 1.6 meters down the plane from the point of collision, it hits a barrier and returns back up the same line of greatest slope. B hits the barrier 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced by 90%. So it loses 90% of its speed at the point when it hits the barrier. So when it hits the barrier, it's going at a certain speed. It won't be the same speed as 3, because it's going, even though it's a smooth plane, if it was horizontal, yes, it would be going at that same speed. But because it's going down the slope, its acceleration, it has acceleration due to its weight going down the slope. There's a force acting on it, which is accelerating it down the slope. So it's going to be some acceleration there. So when it hits the barrier, it's going to be going at a speed more than 3, which we probably have to find. Which is actually, they told us to show that 0. Oh no, that's immediately after. Okay, so before it hits the barrier, okay, we've got to find its speed, and then show that after it's the barrier, its speed is now 0.5 meters per second. After it hits the barrier, after its speed is reduced by 90%. Okay, so then it says the two particles collide again. So A is going down. So basically what's happening here, let's just try and picture what's going on. This is a very complicated scenario here. I don't know what the examiners are thinking when they give questions like this. So we have, first of all, A and B colliding at a certain point. Okay, this is A, this is B, they collide at a certain point. Okay, so let me try and draw them separately so they don't stick together. So A and B collide at a certain point. Okay, so B is going down faster than A, okay, after they collide. B hits this barrier, okay, it hits the barrier. So B is accelerating and A is also accelerating, but B hits the barrier, then he loses like 90% of his speed and comes back up again for a little while. And of course, as it's coming up, it decelerates. And A is just increasingly, it's accelerating down the plane until, boom, they meet and they coalesce. And then we've got to find, in the end, the speed of the combined particle immediately after the second collision. Okay, so basically, at that point, we're going to find what is the speed of this combined particle when they coalesce. So basically, so A and B were both moving down. A was going faster than B. Okay, so A hit B, and B started going faster than A. A's increasing speed, but B's going faster than it. Hits the barrier, comes back up. A's going down, accelerating until they hit again. And we got to find what the speed of that combined particle is when they hit again, they coalesce, they join it as one. So that's the scenario of what we have to do. So far, what we have done is we have found that, let's call this point here, this point, let's call this point X. Okay, this is the point X where they first collided, right? So when they first collided, this is B. It's moving now with the speed at this point of 3 meters per second, as we found over here after the collision. And after the collision, A is moving down with a speed of, and they said its speed was reduced to 2.5 meters per second. So this is like after the first collision. So this is 2.5 meters per second. Okay, now the distance down the plane that B moves, okay, is 1.6 meters, okay, until it hits the barrier. So that distance is 1.6 meters. So B is going to move down the plane, 1.6 meters down the plane, and it's going to hit this barrier. Okay, and it hits the barrier at time 0.5 seconds, or 0.4 seconds after the collision. So if we call this t equals 0, this is going to be, when B reaches here, it's going to be t equals 4.4 seconds. Okay, no, sorry. B hits the barrier is 0.4 seconds. Where did 4.4 come from? 0.4 seconds after, okay, they first collide. B is going to now hit this barrier. Okay, so this B is going to hit this barrier with a certain speed that we don't know. Okay, I know that when it bounces off the barrier, this speed is going to be multiplied by 0.1. Why? Because when you reduce something by 90%, it's 100% minus 90%, which is going to be, it's going to be 10% of what it was. So you take the speed and you multiply by 0.1, that will reduce its speed by 90%. So whatever speed it hit the barrier with, it's going to bounce off the barrier with 90% of that speed. Okay, so, you know, we should now make sure that we get this. We will try and find out what the velocity of B is when it hits the barrier. Okay, so now, so we know that the time it's taken to go this far is 0.4 seconds. We know the distance it's gone through. We know its initial speed. We want to find its final speed in this distance. We could use here suvat. We could even use energy. We could say that we could use potential energy and we could use suvat. Now, if we use suvat, let's say we take this particle B, its weight is 0.2 g, and its component of the weight down the slope is going to be, this is 30 degrees, remember the slope is 30 degrees, it's going to be 0.2 times, this is going to be 0.2 g times sine of 30 down the slope. Okay, so that's going to be the force acting down. So that's the only force acting on it. So we can say that 0.2, if we take down as positive because it's going down, 0.2 g times sine 30 is equal to the mass, which is 0.2 times a. So we can see that the acceleration is g sine theta. We should know that anyway. G times sine of the angle of the incline is acceleration if there's no friction or anything acting, and it's just kind of like only subjected to the weight going down a slope. So that's going to be 10 times a half, which is 5 meters per second squared. Okay, g is 10, sine 30 is a half. Okay, so that's 5 meters per second squared. All right, so this is the acceleration of the particle, 5 meters per second squared, and we can now use suvat to find its speed when it hits the barrier. So s is 1.6, u is 3, v is what we're trying to find, a is 5, and the time is 0.4 seconds. Okay, so we could have actually even done without a. Okay, I could have used 1.6 equals u plus v over 2 times t. I didn't actually have to find a here, to be honest. Okay, I could have found what v is. Okay, so I could have used s equals u plus v over 2 times t. That would have been quicker. Okay, so I'm just discussing that. So s equals 1.6, u equals 3. The velocity of b is what we have to find over 2 times the time, which is 0.4. Okay, so that's going to be 3.2, 2 times 1.6 over 0.4 equals 3 plus VB. So that's 3.2, that's going to be 8 equals 3 plus VB. So the velocity of B is going to be 8 minus 3, which is 5 meters per second. So the velocity of B as it hits the barrier is 5 meters per second. So after it hits the barrier, so the velocity of B after it hits the barrier is going to be 0.1 times 5, which is 0.5 meters per second. Okay, that's the velocity of B after it hits the barrier, and that's what we had to show. Okay, so in fact, I didn't have to even work out the acceleration because I have S, U, I have T, and I want to find V. I can use this formula, which is basically from the area of a trapezium, all right? And, you know, it's constant acceleration. So I didn't have to even work out A. I could just use S equals U plus V over 2 times T, and we get the velocity of B as it hits the barrier. Therefore, if it's reduced by 90%, it's now going to be going at 0.1 times that, okay, on the way back up. All right, so now we have to carry on. I've run out of space. I'm going to go to the other page. So we've got to the stage now where B has hit the barrier and is going back up again. All the while, A is accelerating down the plane. Okay, so let's go to the next page and continue here. All right, so let's make a little new diagram here. So we have, this is A, and this is B after it's the barrier. Okay, so B has basically come down. Whoops. Get rid of the barrier from there. Do that again. Let's draw the barrier with one of these lines. That's the barrier. This is B. What happened to B? Okay, A hit B. B went down. A was accelerating down as well, but slower than B. B hit the barrier and then it started to go up a bit. All the while, as that's happening, A has been going down, boom, and they hit again. Right. So we need to find about what their speeds are when just before they collide again. So what happened is B went down for 0.4, where is it? 0.4 seconds, it hit the barrier. Okay. And then it went up for another 0.04 seconds until it got to the same level here. So basically, in the 0.44 seconds, B has gone down, hit the barrier, and bounced up again. And A has just accelerated down the plane, okay, and it's hit B at that point. Okay, so this is A and this is B. So A has traveled from here to here, starting off at a speed of 2.5 meters per second, ending up at a speed of A, the velocity of A at the point, let's call this point P, okay, where they're going to hit again. We want to find that velocity, okay? We know that it took from time equals 0, the whole of this time, which is 0.44 seconds. 0.44 seconds, that's the time it's been moving down this slope, okay? And it's, you could say that we know the initial velocity, we know the time, we don't know the distance it's traveled, so we need to know the acceleration in this case, which we can work out. The acceleration is going to be g sine 30, because it's smooth, all right? So it's going to be basically 5 meters per second squared, all right? So that's going to be the acceleration down the slope. So we can use suvat to work out what the velocity of A will be when it hits B. So we got S, we don't know. We don't need to know that. U is 2.5. V is the velocity A at P, which we're trying to find. Acceleration is 5, and the time is 0.44 seconds. So we can use V equals U plus AT, V equals U plus AT. So the velocity A at P is going to be U, which is 2.5, plus A, which is 5 times 0.44. So the velocity of A at P is going to be given by, where's the calculator gone? Oops. It's going to be 2.5 plus 5 times 0.44. That gives you 4.7 meters per second. All right, so this is going at 4.7 meters per second before it hits B. All right, so now we got to work out what's happening to B at that same time. Now B has hit this at a speed, it's come off this at a speed of 0.5 meters per second. Okay, and it's going up this with a deceleration of 5. Basically, now it's going this way, and the acceleration is going down the plane. So it's decelerating up the plane. Okay, so acceleration is acting downwards, and it's going the opposite direction. And the time it's gone from here to here is basically 0.04 seconds. Where did I see that? Sorry, 0.4 seconds. Okay, so B hits the barrier 0.4 seconds after the collision, and then when it hits the barrier, speed is reduced. The two particles collide again after. Okay, so basically, it hits the barrier after 0.4 seconds, and then they collide again after 0.44 seconds. So the time that B went from the barrier to the point P is going to be 0.44 minus 0.4, which is 0.04 seconds. So B has been going up here for 0.04 seconds. That's the time it took for B to go from there to there. So let's look at suvat for B, okay? For B going from this point to that point, we're going to have S equals, we don't know, U equals, I'm going to take up as positive for this, so U is equal to 0.5. V is what we're trying to find. Okay, A is negative 5, because I'm taking up as positive and acceleration is down. And the time is 0.04 seconds. So again, we can use suvat, we can use V equals U plus AT. So we can say the velocity of B at P is going to be U, which is 0.5. Again, I'm taking up as positive, plus A, which is minus 5 this time because it's acting down, times the T, which is 0.04 seconds. So the velocity of B at P, of course, is going to get less. So as you have 0.5 times minus 5, sorry, plus, and you're going to have negative 5 times 0.04, the time for which it was rising, okay, which gives you 3/10. So it's 0.3 meters per second. So now we know the situation. There's A, which is 0.4 kilograms. There's B, which is 0.2 kilograms. This is going down and this is going up. The velocity of A as it's going down is 4.7 meters per second. The velocity of B as it's going up is 0.3 meters per second. This is what's happening before. Okay, let me just do something to make it a bit more. Whoops. give me some more space. So this is what's happening before. Okay, and after the collision, what happens is they join together as one particle, which is 0.6 kg, and we want to find what's happening to the velocity after the collision. All right, so we're going to use the conservation of linear momentum. We can say before the collision, you have the mass 0.4 times 4.7, and I'm going to take this direction as positive. Okay, so 0.4 times 4.7 plus the mass 0.2 times minus 0.3 equals the total mass, which is 0.6 times the velocity of the combined particle. So this should give us an answer. So 0.4 times 4.7. It's a long question. That's 47 over 25, which is 1.88. And that's going to be minus 0.2 times 0.6. Okay. But, sorry. Times 0.3. Be careful. Because there's going to become a minus, because these multiply to give you minus. That gives you 91 over 50, which is 1.82. So 1.82 is equal to 0.6 V. Let me just tidy that up. That's equal to 0.6 V. Oh, what a long question. So V is equal to 1.82 divided by 0.6. I wonder how many people actually did this question. It's so long at the end of the exam. So you get 91 over 30, which is 3.03. So 3.033 continues. It's a recurring decimal. So we should round to 3SF. 3.03 meters per second is the speed of the particles as after the collision. Of course, they're going to be going in the direction that we've called down, which is positive, which is down. Okay, but they didn't ask you for the direction, just the speed. Okay, so that's 7 marks, part B alone. It's a lot of work involved there, but we got there in the end with the correct answer. And that completes this question. Number 7 from the May-June 2022 mechanics paper 4, variant 1. Let me just look at the examiner's report just to see. So here we can see what they mentioned in the examiner's report. It's about part B of this question 7. Candidates found this part very challenging and many of them did not attempt it. It concerns the motion of 2 particles in part A after the first collision. The 2 particles on an inclined plane. So basically, you know, this was a very difficult question. A lot of students didn't get to attempt it, especially in exam conditions. I don't know, you know, why they would give such a challenging question. I guess it's the last question. So, you know, my advice to you would be never try the last question first, because you might end up spending so much time on it that you don't get time to finish the straightforward questions. Always leave the last question to the last, so that, you know, at least you don't take up too much time with it. Anyway, that concludes this question from this paper. Other questions from this paper can be found in the playlist that will appear in this section over here. Other questions from the topic of, I guess this is the topic of momentum, right? Momentum. So I'll put the playlist for momentum here. You can subscribe to my channel by clicking on this link over here, and you can watch the video that's linked over here to tell you how to use my channel, find what you need. Thank you for watching, and see you soon.